Hello, welcome back to YouTube channel. Today I'm going to show you guys through an example problem how to work projectile motion problems in physics. So, the question that we are given today is that we have a truck that's 50 meters away from a burning building. It's trying to stop a fire on a building that is 20 meters from the ground. And the water behaves like a projectile and the fire hose is 2 meters above the ground. So the question is asking about the minimum velocity of the water leaving the nozzle and the angle of the hose above the horizontal. So a general strategy when attacking these type of problems is to always first analyze what the problem is saying and draw a diagram. And after that, you would want to draw a coordination system and define the positive directions and break the motion into horizontal and vertical components. That is along the x and y direction because velocity is a vector and can be broken into x and y direction as a result. Now you're going to list the known and unknown data, values, and units. You're going to treat the motion as two independent 1D motions. So what that means is that you want to solve for the x direction and the y direction separately. And we will do that when we solve the problem. Then we will solve one direction at a time. We will get an answer, we will check it, and we will add in units when necessary. So the first step is to analyze the problem, and air drag, air friction neglected, put aside. Any projectile problem can be treated as the combination of two separate motions, vertical free fall or horizontal even speed. So what that means is vertical, if you were to analyze this problem vertically, then it would be a free fall motion. But if you were to analyze the problem horizontally, you'd see that the acceleration is zero because it is even speed motion in a horizontal manner. And the second point to note is that if the water reaches the fire at the maximum point of movement, then the final vertical velocity is zero. And that will be very critical in solving the problem. For the third step, we see that we can therefore conclude that the time for the water and as it reaches to the highest height will be the same as the time to reach the building because of what has been given to us. So for the second step, we need to draw a coordination system and analyze the motion. So we have the velocity, and what we're going to do is we're going to draw the axis. We're going to label the positive directions, in this case rightwards and upwards for x and y respectively. Then we're going to break the motion, break the velocity into x and y components. So for the third step, we're going to list all the known and unknown data and the equations necessary to solve the problem. So for the y direction, we have the change in y displacement is 18 meters because of the information given to us. And we have some other well-placed values, some standard and some given to us. We have various equations in both the x and y directions. And on the bottom table, there is just some other convenient equations that will be very useful when solving the equation. So for the fourth step, we are going to first solve for the y direction because it is easier to solve. We have more values and we can therefore get more unknown values out of it. So what we're going to do is we're going to use the formula VTY squared minus VOY squared equals 2G delta y. And VTY and VOY are the final and initial velocities in the y direction respectively. G is the acceleration, delta y is the vertical displacement. Since we have all these values, we can therefore solve for the initial velocity and we get 18.8 meters per second. Then we're going to apply VTY equals VOY plus GT, another fundamental kinematics equation. And from there we get the time, which is 1.9 seconds. Now for the fifth step, we are going to solve for the unknown data on the x direction. So now the x direction, we now have the change in horizontal displacement and we have the time as from the y direction. So now we can get the x component of the initial velocity. And now to find the initial velocity as a whole with no components, we're going to take the square root of the sum of the squares of the initial velocity in the x direction and the initial velocity in the y direction. And since we have both these values, we can compute it to be 32.3 meters per second. Now we're going to use the formula tan theta equals VOY over VOX. And in order to find theta, we're going to divide and we're going to find the inverse tangent and we get a final value of 35.6 degrees. So thank you guys for watching again, and I will see you guys soon.